Okay. Second video for linear regression. Okay, so we're going to start to get into the idea of our residuals, which a lot of you may be aware of. So in most cases, no regression line is going to pass exactly through all the points in a scatter plot. If it does, we would probably assume that it has a correlation of 1. It would be a perfect linear relationship. More than likely, you're not going to see this, okay? Because we use the line to predict y from x, the prediction errors that we make would be errors in your y or your vertical direction, okay? So you're obviously going to have, we'll call these errors is anything that doesn't fall on the line. So the distance between them would be a vertical direction because the distance would be, the errors would be being made in y. So a good regression line tries to make the vertical distances from the point on the line as small as possible, okay? So these distances, okay, is called a residual. So a residual is the difference between an observed value of the response variable and the value predicted by the regression line. Okay, so the residual is a value, and it is your observed y, okay, minus your predicted y. Okay, often you'll hear residual referred to as a leftover. Okay, because it's kind of the amounts left over after you have your regression line, after you make your prediction. Okay, so the prediction errors are marked as bold segments in the graph. Okay, the residuals there are the bold segments in the graph. The vertical deviations represent the leftover variation in y after fitting the regression line. These are the residuals. Okay, so a negative residual would happen below the line, and a positive residual would happen above. Okay, so let's go back to that Ford F-150. Okay, so let's find and interpret the residual for the Ford F-150 that had 70,583 miles driven at a price of $21,994. Okay, so here comes that linear regression line that we have been using. Okay, and now we're looking for what prediction we would have made for 70,583 miles. Okay, and I would have predicted my price to be $26,759. Okay, but your actual price was $21,994. Okay, this was your actual. To find my residual, okay, I'm going to take my actual and I'm going to subtract my predicted, my y hat. Okay, so my 21,994 minus my 26,759, which gets me a residual of negative $4,675. Okay, in terms of how I would predict this, how I would interpret this is that the actual price of this truck is $4,765, lower than than we expected it. Okay. So now let's talk about the least squares regression line. So a regression line should try to make those residuals as small as possible. A good regression line tries to make those residuals between your points and the line as small as possible. Okay, different regression lines are going to produce different residuals. Okay, the regression line we want is the one that minimizes the sum of the squared residuals. Okay, this we refer to as the least squares regression line of y and x, and it's is the line that makes the sum of the squared residuals as small as possible. Okay, so just as far as what we're looking at, so this graph right here, so you can see your residuals in graph to the left over here, this graph right here shows the squared residuals for all the trucks. No other regression line would give a smaller sum of the squared residuals. Okay, so this line in this graph would be the least squares regression line because no other line would get a smaller sum. Okay, so now to understand whether we can actually use a linear model, so whether a linear model is actually appropriate for our data or not. Okay, so one of the first principles of data analysis is to look for an overall pattern and for striking departures. Okay, a regression line describes the overall pattern of a linear relationship between two variables. We see departures from this pattern by looking at the residuals. Okay, a residual plot is a scatter plot, but it's a scatter plot of the residuals against your explanatory variable. So your residual plot is going to help tell you whether or how well, I shouldn't say whether it does or not, but how well your regression line fits the data that you have. Okay? Okay. So here's the scatter plot that we had of the miles driven on a F-150 and the price that it's at. Okay? Here's a residual plot over here. Okay, so what a residual plot does is it takes your linear regression line. This is your linear regression line, but it now makes it horizontal. Okay, and it makes it horizontal at 0. Okay, so these are your plots, your explanatory variables against your residuals against your explanatory variable. Okay, so what you're looking at is there a pattern with your residuals, okay? I see absolutely no pattern going on in this residual plot, okay? To me, this appears to be random scatter, okay? Random scatter on a residual plot would imply that there's no pattern in your leftovers, in your residuals. Okay? When you have no pattern in your residuals or your leftovers, okay, that means your regression line did what it wanted to do, okay? You had no pattern left over. That means your least squares regression line did what it was supposed to do. It explained to the best that it can the smallest sum of squares of your residuals, okay? Random scatter implies that this linear model is appropriate to describe this data. Okay, so let's kind of look at what happens or what we're looking for and when it's not good. Okay, so a residual plot magnifies the deviations of the points from the line. It's making it easier for you to see unusual observations and patterns, okay? So you wouldn't normally see them on your scatter plot, okay? You wouldn't see a pattern that's happening in your leftovers, okay? But you would see that pattern on a residual plot because you're plotting the difference in your observations and your predictions with your explanatory variable, okay? The residual plot should show no obvious pattern, okay? Like I said before, you want absolutely random scatter. That's showing you that you don't have anything left over that's that shouldn't be there, that your line is explaining exactly what you want it to in your data. The residuals should be relatively small in size, okay? So if we look at this residual plot, okay, this residual plot turns, it definitely has a leftover pattern here. You see a pattern in the residuals, okay, right here. This was your regression line turned horizontally at 0, okay? And because it shows a pattern in your residuals, this is not an appropriate regression line to use for this, or it may not be appropriate to use a linear model at all, okay? What the scatter plot looked like here, okay, was as followed, okay? And it doesn't always mean that it's as obvious as this, okay? We would expect not to see much going on that we'd want in the residual plot because this was curved. So I don't think we would have went for a linear model. But it doesn't always mean that it's got to be as obvious as this one. Sometimes it may not be, okay? But you definitely don't want to see this pattern, the pattern that you have in this scatter plot, okay? In the residual plot. This is the scatter plot that went with it, okay? Okay, so now to talk about your standard deviation of your residuals, okay? So if we use a least squares regression line to predict the values of the response variable y from an explanatory variable, the standard deviation of the residuals is given as, okay? But another thing that we're not going to calculate by hand, okay? So let's understand what this is, okay? Well, I guess we can really just understand why we need it, okay? Part of why we need it